All right, 11.4 now is drawing organic molecules. We're going to talk about three different ways of how to draw organic molecules. I don't care which way you draw it. I'm going to draw it pretty much all the ways, just so that you can kind of see all the different ways of drawing it and how they all mean exactly the same thing. Um, this form is, I call it in full glory. All right, I don't know if there is actually an actual name when you put all the carbons and all the bonds with the hydrogens. Okay, but this slide is talking about a condensed structure. Okay, where all the atoms are drawn. Okay, and the lone pairs are there, and I'm sorry, the lone pairs are omitted. You don't draw the lone pairs. Okay, so this isn't really a great example. Let me see if there's another one. So here, let's just put one here, like CH3, CH3, CH2, the ethanol example. Okay, so these are in full glory. A condensed form is where you see here I have a carbon with 3 hydrogens. So it's basically a CH3 group. This is a CH3 group. Okay, and it's attached to a CH2 group that's attached to another CH2 group that's attached to another CH3 group. So it's basically the carbon with however many hydrogens around it is a kind of group. So notice this is the condensed form, CH3, CH2, CH2, CH3. Another way of drawing it, which I kind of like to do, is actually putting bonds in between them. I'm okay if you do this. I think it actually breaks it up a little bit better, so that you can actually see where everything is. This, I think, kind of can get a little cluttered at times. Okay, so in this case, in this condensed form, you write the heteroatom, but you don't have to write the lone pair. So I have a CH3, I got a CH2, and I have an OH. So the way you draw this is CH3, CH2, OH. Or you can draw it with the lines in the middle if you wanted to, OH. Okay, so this is a condensed form. I don't think this is too hard to kind of understand when you're starting out. I know you guys are just starting out. Some of you, this is the first time you're ever seeing organic molecules. But just understand that this is how it's grouped. It's basically carbons and hydrogens, a whole bunch of carbons and hydrogens in there. Okay, so start learning, how to draw these and see these. Um, so, here they're kind of showing you what do you do if you have a single hydrogen in a group that's hanging off. Okay, um, I, this is okay. I prefer, again, you do what is easiest for you. All right, I prefer to actually draw the single hydrogen down like that. I don't like drawing a CH. I think that looks cluttered and confusing. Okay, it's important that you know this because your book is going to do this and you're going to have problems in your book that do this. So you have to understand what this means, but I like to draw it like this. So it kind of, anytime I have a single hydrogen, I like to actually draw it down. So this is kind of like a combination of the full glory view and a condensed view. Okay, so they're just kind of showing you if you have a CH, what do you do in that case? Well, you could put it in here if you wanted to. If you wanted to do that, that would be fine. Okay, I just don't like it. I'm not going to mark off on exams or anything if you do it. I just like to show that hydrogen. All right. This is in an even more condensed way. I do not like this way at all. Okay, this is like an algebraic way, but you need to understand it because you're going to see it in homeworks. But I'm not going to draw it like this. And this is basically, imagine you have a very long chain and you have the same groups next to each other. 2 of the exact same groups attached next to each other. Instead of putting a CH3, CH2, CH2, what you do is you do a CH2. Well, I have 2 of these, so let me just put a 2. Okay, it's kind of like, you remember in Gen Chem, I don't know if you have like, let's do like calcium chloride or something, or no, I don't know, I can't think of something right now, but if you have like a sulfate and you put a 2 outside of it, okay, so that's kind of what like this is showing you. It's showing you I have 2 SO4s. This is saying I have 2 CH2s. All right. Sometimes what they do is they have 2 of the same, again, 2 of the same groups attached to the same carbon. They will do it even more condensed form. So I have a CH, this CH, but there are two CH3s attached to it. Okay, you have to remember carbon always makes 4 bonds. So you might be confused, like, okay, this carbon is only showing like this hydrogen's attached to it. What else? You know, well, these two CH3s are attached to it, and then that carbon's attached to it. All right, this just takes getting used to. You might not be seeing it right now, but when you start doing problems, you will start seeing it. And, you know, it's imperative that you do a lot of problems. Okay, so here's kind of a practice problem. Um, Convert these into condensed structures. All right, so put your computer on pause, hit pause, and do the problems. Okay, ready? Go. Welcome back. If you do not put it on pause, and I just said welcome back, and you're like, what's going on? Put it on pause and do it, because I'm about to give you the answer. Okay, so here's the answer. If you didn't do it, put it on pause. I'm going to give you the answer now. Okay, so here we go. Notice we have a CH3 group here. Here's a CH group, a CH2, a CH, a CH3, a CH3, and a CH3. So I have a CH3, that's this group, attached to a CH. I like to draw it up. You don't have to. If you drew it in here, that's fine. This carbon is attached to another CH3 group. And then we have another CH2, we have a CH2. We have a CH with a CH3 attached to a CH3. So that is how I would draw it in a condensed form. In this case, notice CH3, CH2, CH2O, CH2Cl. So CH3, we didn't really talk about how to do this, but hopefully you came up with something. And if you're wrong, that's okay. Part of learning is being wrong, is the CH2Cl. So that is how I would draw that. Okay, like I said, you don't have to do lone pairs. If you would like to, you can. I think right now, because you're still kind of learning how to do these, it might be imperative that you write the lone pairs and to make sure you still know everything's octet. Okay, so here's kind of how they do it. All right, so they actually even go further. So like I said, I do not like this. If you did that, that's great. You understand it, but I'm not going to do those types of structures. This is kind of what I prefer. Okay, and then here's even more. So here's kind of what I did. But again, I put the lines in the middle. Okay, makes sense? I hope we're good. Okay, the second type of structure, this can be very confusing for new people. You kind of have to get used to this. And this is a skeletal structure. Notice you remember the capsaicin molecule? Okay, if you don't, go back to it. But you don't have to memorize it. Just realize there was a lot of carbons and hydrogens on there. Imagine if you had to sit there and write out every single carbon and hydrogen, and you had to redraw that molecule like 5 times or something. That would kind of take a long time. All right. Well, there's an even more simple way of drawing larger molecules, or any molecule, where you don't have to draw in all the carbons and hydrogens. Okay, because it's an organic molecule. So what does my organic molecule always have? Carbons with hydrogens on them. Okay, so what you do is you draw a skeletal structure. Basically, you are just drawing the bonds. You don't even draw the atoms. You're drawing the bonds. Okay, so assume there is a carbon atom at the junction of any 2 lines, or at the end of any line. So if I were to draw that structure, this is what we're talking about. That is the structure of a 3-carbon organic molecule. So what does this mean? Okay, well, assume there's a carbon at the junction of 2 lines, which would be right here, okay, and at the end of the lines. So there's a carbon here, there's a carbon here, and there's a carbon here, and so you're like, well, how many hydrogens are there? Well, it's the maximum number of hydrogens that make it an octet. So if I have a carbon at the end of the chain, so this carbon, so here I have a carbon here, it's bonded to another carbon. How do I know that? There's a carbon here, there's a carbon there. Well, there's nothing else attached to this, so how many hydrogens are there? Well, there has to be 3 hydrogens. That has to be a CH3. This is attached to 2 carbons, so how many hydrogens? There are 2 hydrogens. And this is attached to only 1 other carbon, so how many hydrogens are on here? Well, there has to be 3. Okay, so here is the full glory view, but this is the skeletal. So rather than drawing CH3, CH2, CH3, just boom, boom, you're done. And draw it with the correct bond angles. You always want to draw the correct bond bond angles. Okay. So also assume there are enough hydrogens around each carbon so that there's 4 bonds, or there's an octet. Draw all heteroatoms and the hydrogens directly bonded to them. So for example, if we have CH3, CH2, OH, I'm going to draw it like that. Okay, or if you wanted to, you could also draw it like this. Okay, so this CH3 is that carbon, this CH2 is that, and then you have your oxygen and your hydrogen. All right, so they're going to show you a bunch of problems. You really see them a lot in cyclical structures, because imagine trying to write this. I mean, imagine I had an OH here. You know how confusing that'd be? You see all these H's in OH. You might not even see that you have an OH there, okay, because all these hydrogens are covering it. All right, so skeletal structure of that would look like that. That's obvious. That's a 6-membered ring with carbons and an OH on it. This is like, oh my goodness, what in the world is there? Okay, so that's kind of why we do it. It's really good on ring systems, but you can draw it on anything. Okay, so there you go. It's like the slide could read my mind, or I can see what's next with the slides or something. Who knows? Okay, honestly, I didn't know that this was next. All right, so that's the skeletal structures. All right, so hopefully this makes sense, and I will see you at 11.5 at the next